Beneath the grey, restless surface of the North Sea between Britain and the European mainland, there is a place that should not exist on any modern map. It has no cities standing above the water, no towers, no walls, no carved gate waiting to be found. And yet, it was real. Not a legend, not a fantasy kingdom, not a convenient myth invented after the fact, but a vast human landscape now buried under waves, sand and silt. We call it Doggerland. Today, ships pass over it without seeing it. Fishing nets scrape above its buried river valleys. Oil and gas surveys send sound waves into the seabed, and those echoes return with something extraordinary. The outlines of a vanished world, ancient channels, low hills, former wetlands, layers of peat that were once marshes, forests and reed beds. A country-sized plain where the North Sea now rolls in cold grey silence. 8,000 years ago this was not sea, it was land. Rivers crossed it, animals moved through it. Red deer, aurochs, wild horses and other creatures followed the seasons across open ground. Mesolithic people made camps along waterways that have no names today, because the people who named them are gone, and the rivers themselves are drowned. For generations this world was not strange, it was not lost, it was home. The ground beneath their feet was solid, the horizon was familiar, the routes, the hunting places, the gathering grounds, the stories tied to certain bends in the river, all of it belonged to a living map. And then the map was erased, not in a single night, not by one cinematic wave swallowing everything at once. The force that removed Doggerland was slower, quieter, and in some ways more terrifying. It was the return of the oceans. At the end of the last ice age, the great continental ice sheets began to melt. Water that had been locked away for thousands of years in frozen masses, kilometres thick, flowed back into the global ocean. Over time, sea level rose by roughly 120 metres, about 400 feet. That number is easy to say, but difficult to truly imagine. It means the coastlines of every continent moved. It means lands that had held animals, rivers, people, camps, paths, and memories were gradually taken below the waterline. In some places, the sea did not simply move the shore inland. It consumed entire worlds. Doggerland is the first clue in our investigation because it proves the principle. A human landscape can be real, inhabited, meaningful, and then physically removed from view so completely that later generations must rediscover it with sonar, sediment cores, and fragments pulled from the seabed. And once we understand that, a much larger question opens. What if the missing chapters of human history were not hidden by conspiracy, but removed by the Earth itself? What if the deepest gaps in the ancient record are not empty because nothing happened there, but because the places where it happened are now underwater, buried, eroded, dissolved, or sealed beneath layers we have barely begun to read? What if the past we call known history is not the whole story, but only the portion that survived in the right materials, in the right places, under the right conditions? This is not a search for one simple lost empire. It is not a claim that every drowned coastline hides a forgotten Atlantis. The question is more serious than that, and perhaps more unsettling. If the most productive places for human life were coastal plains, estuaries, river mouths, lake shores and wetlands, then many of the best places to live in the Ice Age were also the easiest places for the rising sea to erase. The archive is broken, not because someone necessarily destroyed it, not because every missing page was deliberately hidden, but because wood rots, fibre disappears, camps vanish under mud, shorelines move, rivers change course. A fishing village built from reeds and timber can vanish without leaving a monument behind. A boat can decay, a path can be drowned. A story can survive only as a warning, a ritual, a name, or a memory that later people no longer fully understand. So the true mystery is not simply what we have found. It is what the Earth did not allow us to keep. In this investigation, we will follow that problem across ice, water, mud, stone, and memory. We will begin with drowned landscapes like Doggerland, then widen the map to the Ice Age world, when the seas were lower and entire regions existed where modern maps show only water. We will move to Beringia, not as a narrow bridge, but as a vanished homeland tied to the first deep chapters of the American story. We will stand at White Sands, where footprints older than the old timeline press human presence into ancient mud. We will descend into the dark water of Page-Ladson, where preservation and erasure become the same force, and from there we will follow the climate itself into instability, the warming after the Ice Age, the sudden cold of the Younger Dryas, the hidden engine of the Atlantic, the glacial lakes that could burst, and the floods powerful enough to carve the face of a continent. Only then can we return to the deeper question. If water, ice, sediment, and time can remove whole landscapes from the map, how much of early human memory survives only in fragments, in earthworks, in footprints, in myth, in stone, and in stories of a world that changed? To see what was lost, we must first unlearn the map we think we know. The coastlines we trace today feel permanent because we were born into them. They appear stable on maps, borders, school atlases, satellite images, and weather reports. But in geological time, they are temporary lines. The modern shoreline is not the natural edge of the world. It is only the current position of the sea. During the coldest phase of the last ice age, the planet looked radically different. A vast amount of Earth's fresh water was not moving through rivers or falling as rain. It was locked inside continental ice sheets, frozen into immense white masses covering much of North America, Greenland, Scandinavia, and parts of Eurasia. Some of these ice sheets were kilometers thick. They were not just landscapes of ice, they were planetary storage systems, holding back enough water to lower the oceans on a global scale. At the height of this cold world, sea level was roughly 120 meters lower than today. That single fact redraws the Earth. The change did not merely create wider beaches, it exposed the continental shelves, the shallow margins around the continents that now lie underwater. These places were not empty, lifeless seabeds waiting to be flooded. They were dry land, plains, valleys, river systems, wetlands, forest edges, grasslands, migration routes, animal habitats, human territories. In some regions, lands now separated by open water were connected into one continuous world. Britain was joined to Europe through Doggerland. Southeast Asia was reshaped by the vast exposed shelf of Sunderland. Siberia and Alaska were connected through the immense region of Beringia. The world was not just colder, it was physically larger for human beings walking across it. This is where the investigation becomes more than a story about sea level. It becomes a story about archaeological blindness. The places most likely to attract human life are often the places least likely to survive in the record. River mouths offer fish, birds, fresh water, transport, plants, and seasonal abundance. Coastal plains offer access to both land and sea. Estuaries gather life from many systems into one place. These were not marginal zones. They may have been among the richest human environments of the late Ice Age, and many of them are now gone. This means the archaeological record does not show us a complete human past. It shows us a filtered past, a selected past, a damaged past. We do not simply study what ancient people did. We study what time allowed to remain. The most desirable real estate of the Ice Age may now be the seafloor. That realization changes the entire meaning of lost history. A missing site is not always a sign that people were absent. A missing settlement is not always proof that no settlement existed. A missing chapter may simply mean that the page was written on a shoreline, and the shoreline no longer exists. This is the world we now have to enter. A planet with different coastlines, different routes, different centres of life, and vast human territories now hidden underwater. And one of those vanished territories holds a central place in the story of an entire hemisphere. Of all the lands swallowed by the rising sea, Beringia may be one of the most misunderstood. The word often brings to mind a simple picture: a narrow land bridge, a strip of frozen ground connecting Asia and North America, something people crossed on their way to somewhere more important. In that version, Beringia is only a hallway. But that image is far too small. Beringia was not merely a bridge, it was a world. At its greatest extent, this exposed land stretched across a vast region between northeastern Asia and northwestern North America. The National Park Service describes it as reaching nearly 1,000 miles from north to south. It was not a thin path across the water, but an immense Ice Age landscape with its own climate, ecosystems, animals, and human possibilities. To understand the deep history of the Americas, we have to stop imagining Beringia as a crossing and begin imagining it as a homeland. For thousands of years, this region formed part of the Mammoth Steppe, one of the great vanished ecosystems of the Ice Age. It was not a lush green pasture, and it was not a lifeless frozen desert. It was cold, dry, and open, a world of wind, grass, sedges, herbs, and immense horizons. Trees were limited, but the ground supported highly nutritious vegetation. That vegetation fed enormous herds, mammoths, steppe bison, wild horses, caribou, and where the herds moved, predators followed. So did human hunters. This was not a place people simply rushed through. It was a challenging but productive environment, capable of sustaining communities over long periods. Archaeological and genetic models suggest that ancestors of the first Americans may have remained in this broader Beringian world for thousands of years, a period sometimes called the Beringian standstill. If that model is correct, then the story of the Americas does not begin with a quick crossing. It begins with generations of adaptation in a land that is now mostly submerged. That point matters. It means one of the foundational stages of American deep history may have unfolded on ground that modern archaeology can barely reach. The rivers where people may have fished are now channels beneath cold, shallow seas. The hills where they may have watched animal movement are now shoals. The camps, paths, and seasonal places that made up their world are hidden beneath the Bering and Chukchi seas. The stage itself was removed, and the story is not simple. The peopling of the Americas is not one straight line with one route and one date. Researchers continue to debate multiple models: inland corridors, coastal migration routes, different waves of movement, and the possibility that boats carried people along shorelines that are now underwater. The details remain complex, but the central fact remains powerful. The American story does not begin only on the continent we see today. It begins partly on a vanished land. Beringia gives us scale. It shows us that entire human worlds can disappear from the map. But scale alone is not presence. A drowned continent can feel abstract. A bathymetric chart can show a lost valley, but it cannot show a human being walking across it. For that, we need a different kind of evidence. Something smaller, more fragile, more intimate. We need a footprint. The search now moves from the drowned northern edge of the Americas to a dry lake bed in what is now New Mexico, at White Sands National Park. Here, deep time suddenly becomes personal, not a city, not a monument, not a wall, a steppe. Imagine the edge of ancient Lake Otero more than 20,000 years ago. The ground is wet, soft, gypsum-rich mud. Someone walks across it. Their heel presses down, their toes spread slightly in the surface, their weight shifts forward. Nearby, the tracks of mammoths and giant ground sloths mark the same vanished landscape. For one brief moment, a human journey and an Ice Age world touch the same piece of ground. Then the moment ends. The mud dries. New layers cover it. Time passes over it. The person disappears from history, but the pressure of their step remains. For decades, the dominant story placed the first widely accepted human presence in the Americas around 13,000 years ago. White Sands has forced that story to widen. Multiple studies, including work on ancient seeds found in the footprint layers and analysis connected with the US Geological Survey, have dated the tracks to roughly 21,000 to 23,000 years ago. That places people deep inside North America during the last glacial maximum, when huge ice sheets still covered much of the continent. Because this discovery changes such a fundamental timeline, the dating has been debated and tested with unusual intensity. That is exactly what should happen. But the evidence for a much deeper human presence in North America is now substantial enough that the old, simple timeline can no longer stand untouched. And yet the power of White Sands is not only in the date, it is in the kind of evidence it gives us. These footprints do not prove a city. They do not reveal agriculture, kings, writing, machines, or a lost empire. They show something quieter and, in some ways, more difficult to forget. They show people in motion, children and teenagers moving along a lakeshore, adults crossing wet ground. One trackway has been interpreted as a person carrying a child, the body shifting under extra weight, the path marked by pauses and changes in pressure. This is not the archaeology of a state. It is the archaeology of a moment, and that moment is enough to change how we feel the deep past. It reminds us that ancient history was not made only by monuments. It was made by bodies moving through weather, mud, hunger, danger, kinship, and memory. A human presence can be ancient and profound without leaving behind pyramids or walls. But it also raises a more unsettling question. If one set of footprints survived because mud, dryness, burial, and chance aligned in exactly the right way, how many billions of other traces vanished? How many camps washed away? How many paths were erased by rain? How many shorelines were drowned before anyone could ever study them? How much of the human story was real, lived, and meaningful, but never preserved in a form we could find? The footprint at White Sands survived because the water left. The archive was sealed when the lake dried. If there is an ancient place near you, a mound, a petroglyph, a shoreline, a cave, a place name, or even a local story tied to the land, hold it in mind as we continue. These small traces may be part of a much larger memory of the Earth than any single map can show. This leads to a different kind of question. What happens when a trace is left in a place where the water never leaves? The tracks at White Sands were preserved in dry mud, a fleeting moment captured by the sun. But another American trace, older than the timeline once allowed, waited in darkness, sealed away by water. It was found in northern Florida, in the Orcilla River, at a place called the Page-Ladson site. For decades, divers entered that dark, tannin-stained water, descending into a sinkhole in the riverbed, where visibility could be so low that discovery depended as much on touch as on sight. Beneath layers of sediment that had not seen daylight for millennia, they found what dry land had failed to keep: stone tools, and more than tools. They found the remains of a mastodon, an extinct relative of the elephant, bearing clear marks made by human action. The layers were carefully studied and dated. The evidence placed human activity at the site around 14,550 calibrated years before present. This was a direct confirmation of pre-Clovis presence in the Americas, people living in a world of megafauna long before the older, narrower model allowed. Page-Ladson matters because it changes the role of water in our investigation. Until now, water has appeared as the great eraser, the force that drowned Doggerland, the force that submerged Beringia, the force that moved coastlines and removed whole landscapes from sight. But here, in the right conditions, water becomes something else. Cold, dark, low in oxygen, sealed away from the ordinary cycle of decay, it becomes a vault. Bone can survive, wood can survive. Organic traces that would vanish quickly on open land can remain hidden for thousands of years. This is the paradox at the heart of the broken archive. The same element that erases whole worlds can preserve a single fragile trace. Water destroys the map, then hides the evidence inside itself. Page-Ladson, therefore, does more than push back a date. It complicates the logic of loss. It tells us that the American deep past is older and more complex than the old models allowed. But it also tells us something larger. The archive is not only broken, it is hidden. Some evidence survives precisely where we least expect to find it, in submerged, difficult, dangerous places that demand a different way of looking. White Sands shows what can survive when water leaves. Page-Ladson shows what can survive when water stays. Together, they change the investigation. We are no longer asking only what people built, or where they moved, or how early they arrived. We are asking what kind of planet they lived through, and how unstable that planet really was. The traces we find, whether footprints in dry gypsum mud or tools in a dark riverbed, can feel stable because they are fixed in place. But the climate around those traces was not stable at all. After the deep freeze of the last glacial maximum, the world began to thaw, ice sheets retreated. Plants returned, forests advanced, animals shifted their ranges. For nearly 2,000 years, during a period scientists call the Bölling Allerud, warming took hold across much of the North Atlantic world. To people living through it, this may have felt like a promise. The worst cold was ending. The world was becoming warmer, wetter, and perhaps more reliable. But the Earth had not finished changing. Our knowledge of this false spring comes not from human memory, but from the memory of ice. Deep inside Greenland, scientists have drilled cores that preserve ancient climate signals layer by layer. Each band of compressed snowfall holds chemical traces of the atmosphere that formed it. The oxygen isotopes in that ice work like a deep-time thermometer, recording shifts in temperature across thousands of years. And in that record, the story suddenly turns. The warming does not simply slow, it reverses. In the span of a few generations, temperatures in the North Atlantic region plunged back toward Ice Age conditions. The cold returned with shocking force, and remained for more than 1,000 years. This interval is known as the Younger Dryas. It began around 12,900 years ago and lasted until roughly 11,700 years ago, holding much of the northern hemisphere in a state of renewed climatic stress. For the people on the ground, this was not a graph. It was a betrayal of the seasons. The plants they knew would have shifted, animal migrations would have changed. Water sources, hunting grounds, shorelines, and travel routes may have become unreliable. Communities living on the plains of Beringia, along shifting coasts or near lakes and rivers, were not adapting to a gentle linear warming. They were living through climatic whiplash. A world that had seemed to be emerging from the Ice Age suddenly turned back toward it. And that raises one of the most important questions of the entire investigation. What force could interrupt the planet's recovery so violently that the climate system itself seemed to reverse direction? This raises the central question of the entire period. The planet was on a clear path out of the ice. What force could be powerful enough to not merely halt that process, but to throw the entire climate system into reverse with such alarming speed? The Younger Dryas establishes a crucial reality. The ancestors who survived this period were not adapting to a gentle linear warming. They were navigating a world of violent climatic whiplash. This instability becomes a central character in the human story, a force capable of rewriting the rules of life on a continental scale. The search for its cause would lead scientists away from the land and the ice, and toward an invisible engine of heat hidden within the ocean. The sudden cold of the Younger Dryas, recorded so clearly in the Greenland ice, leads the investigation away from the land and out into the dark water of the North Atlantic. The question is not just what happened, but how. How can an ocean, a body of water, so profoundly change the air for more than 1,000 years? The answer may lie in an invisible system, a current of immense scale and power. To understand it, it helps to think not of a chaotic sea, but of a great organized conveyor belt. This system, known to science as the Atlantic Meridional Overturning Circulation, or MOC, is one of the planet's primary engines for moving heat. The process begins in the warm tropics, where surface water, heated by the sun, flows northward. As this current travels, it carries enormous quantities of thermal energy with it, acting like a current of warm air, moderating the climates of places like northern Europe. As this water moves north, two things happen. It releases its heat to the colder atmosphere, and some of it evaporates, leaving the remaining water saltier. Cold, salty water is denser than warm, fresh water. Eventually, in the seas near Greenland and Iceland, this surface water becomes so cold and so dense that it sinks. It plunges thousands of feet toward the ocean floor, where it begins a slow journey back south. This sinking is the critical step. It is the engine of the conveyor, the downward pull that draws the next wave of warm water north behind it. For thousands of years, this rhythm can remain relatively stable. But the system has a vulnerability. What happens if you suddenly pour a vast quantity of cold, fresh water onto the surface of the North Atlantic? Fresh water is not as dense as salt water. It is lighter. It will not sink. Instead, it can spread out across the ocean's surface like a lid, insulating the warmer, saltier water below from the cold air above. The sinking process slows, or in some models stops altogether in key areas, and if the sinking stops, the northward pull of the conveyor belt weakens. The delivery of heat is interrupted. This process is what researchers call freshwater forcing. It's a leading, though still debated, explanation for the abrupt onset of the Younger Dryas. It provides a physical mechanism that connects the melting ice of the Bulling-Alarud warming period to the sudden, hemisphere-altering cold that followed. It suggests that a change far away, the release of meltwater, could have a dramatic consequence for people living thousands of miles from the source. This gives the investigation a concrete chain of events to follow. But it also raises the next urgent question. If a flood of fresh water was the trigger, where did it come from? The search for that source leads us back inland to North America, and to a body of water that no longer exists, a glacial lake larger than all the Great Lakes combined. The mechanism of the Atlantic Meridional Overturning Circulation provides a powerful theory for how climate could change so abruptly. But it requires a key ingredient, a truly enormous volume of fresh water, delivered to the right place at the right time. The investigation must therefore move inland, away from the ocean, to search for a reservoir capable of holding such a charge. The prime candidate has a name, Lake Agassiz. To picture Lake Agassiz is to picture a lost inland ocean. At its greatest extent, it was larger than all of the modern Great Lakes combined, covering an area greater than the state of California. It was a vast, cold, freshwater sea that existed where parts of Manitoba, Ontario, Saskatchewan, North Dakota, and Minnesota are today. But this was not a lake held in a stable basin of rock. It was what geologists call a proglacial lake, which means it was formed by the meltwater of the retreating glaciers and dammed on at least one side by the ice sheet itself. The southern edge of the colossal Laurentide ice sheet served as a shifting, unstable, and ultimately temporary northern shore. For thousands of years, this immense volume of water grew, its pressure building against a decaying wall of ice. The stability of the entire system depended on the integrity of that ice dam and the elevation of its outlets. As the climate warmed and the ice thinned, new, lower drainage paths could open suddenly. It is this inherent instability that places Lake Agassiz at the centre of the Younger Dryas question. Researchers continue to debate the exact sequence of events, which outlets failed, in what order, and precisely when. Some models point to drainage north, through the Mackenzie River system into the Arctic Ocean. Others suggest routes east, toward the Great Lakes and the St. Lawrence Seaway, and from there into the North Atlantic. The evidence in the sediment is complex, and the timing is a matter of intense and ongoing study. But the central dramatic possibility remains. At some point, the pressure of that inland sea found a catastrophic release. When a lower outlet opened, a glacial outburst flood would have begun, draining unimaginable quantities of cold, fresh water away from the continent and into the global ocean system. This is the event that provides a concrete North American source for the freshwater forcing that could, in theory, have diluted the North Atlantic and disrupted the Amo Sea. It is a plausible physical connection between a melting ice sheet in the heart of a continent and a sudden lurch back to glacial conditions felt across an entire hemisphere. To understand the sheer power of such a release, we can look at a place where the evidence is not in the ice cores or ocean sediments, but is carved permanently into the bedrock of the land itself. To understand what a glacial outburst flood can do to a landscape, we can leave the realm of computer models and travel to a place where the evidence is carved into the bedrock itself. In eastern Washington state, there is a vast terrain that looks as though it has been scoured clean by an impossible force. This is the channeled scablands. To the unprepared eye, it is a bizarre and empty landscape. There are canyons with sheer, 1,000-foot cliffs, but no rivers at their bottom. There are dry waterfalls, wider than Niagara, that have not seen water for more than 10,000 years. And most strangely, there are ripple marks, like the kind you might see in sand on a beach, but these are hundreds of feet apart and etched into solid basalt rock. For decades, geologists debated how such a place could form. The answer, when it was finally accepted, was as dramatic as the landscape itself. During the last ice age, a lobe of the Cordilleran ice sheet crept south, acting as a natural dam and blocking the Clark Fork River. Behind this dam of ice, water backed up, forming glacial Lake Missoula, a body of water that held more than 500 cubic miles of water, as much as Lake Erie and Lake Ontario combined. Periodically, the pressure of this immense lake would lift the ice dam, causing it to fail catastrophically. The entire lake would then drain in as little as 2 days. A wall of water, ice, and debris would roar across Idaho, Washington, and Oregon, moving at speeds of up to 65 miles per hour. This was not a flood that simply covered the land. It was a torrent with the power to strip away hundreds of feet of soil and solid rock, to reroute rivers, and to carve this wounded landscape into existence. And this did not happen just once. It happened dozens of times over several thousand years. The geological event itself, from the dam failure to the draining of the lake, could be over in a matter of a week. But the scars it left on the face of the continent are, for all human purposes, permanent. It is tempting to look upon the channeled scablands and see the physical proof of the world's great flood myths. But its function in this investigation is more specific and more crucial. The scablands are not being presented as the literal source of a story told in Mesopotamia thousands of years later. They are a physical lesson in scale. They are an imaginative tool. They prove, without any ambiguity, that water can behave with a violence that defies our daily experience. They show that an event that would feel utterly mythic to any human observer can be a real, physical process. A flood like this is a dramatic, singular event. But the greatest eraser of the ancient world was not a flood that came and went. It was the slow, relentless return of the sea, a flood that never receded. The scars left by the glacial floods in the channeled scablands are a testament to the power of fast water. They show what can happen when a massive volume is released in a short, violent span of time. But the most widespread and persistent agent of erasure at the end of the Ice Age was not a single flood, but a slower, more relentless force, the steady return of the sea itself. As a baseline, the physical fact is not in dispute. Since the peak of the last glacial maximum, the melting of the world's great ice sheets returned immense quantities of water to the oceans, raising global mean sea level by roughly 120 metres, or about 400 feet. This was not a single event, but a process unfolding over thousands of years. For the people living on the coasts, it would have been experienced as a generational truth, the knowledge that the shoreline was not fixed, that the sea was always moving inland. The fishing grounds of one's grandparents might be deep water for one's grandchildren. Within this long, slow inundation, however, researchers have searched for episodes of extreme speed. The question is whether the melting was always gradual, or if it sometimes happened in dramatic bursts. This search has given rise to the concept of meltwater pulse 1b, a debated period proposed to have occurred near the end of the Younger Dryas, around 11,400 years ago. In this scenario, the rate of sea level rise may have accelerated dramatically, causing a rapid jump of several metres, or more than a dozen feet, in just a few centuries. It is a compelling image, a period where the slow advance of the sea suddenly quickened its pace. But it's essential to mark this as a topic of ongoing scientific investigation. The timing, the exact rate, and even the global uniformity of this specific pulse are not settled. Different proxy records, like the analysis of drowned coral reefs in different parts of the world, provide a complex and sometimes contradictory picture. The idea of a single, coordinated, cinematic pulse of water is powerful, but the evidence for it remains a living debate. And here is the crucial turn. Whether the rise happened in a series of faster pulses or as a more continuous grinding advance, the final result for coastal peoples was the same. The 120 metres of sea level rise is the fundamental world-altering fact. The coastlines moved. The familiar river valleys, hunting grounds, and sacred sites of the low-lying plains were, in the end, submerged. The power of this transformation does not depend on a single dramatic meltwater event. The quiet, unstoppable pressure of the rising ocean was enough to erase a world. With this dual mechanism of erasure now clear, the violent landscape-carving power of outburst floods, and the slow, inexorable rise of the global sea, we can return to the places themselves. The investigation can now travel to a landscape that was once a heartland of ancient Europe, before it vanished beneath the waves. The investigation now returns to where it began, not to the idea of a lost world, but to a specific place. We return to the grey, windswept surface of the North Sea, to the water that now covers the low plains of Doggerland. When we first stood here, it was an act of imagination, picturing a landscape that no longer exists. Now, we return with the tools of an investigator to examine the file of evidence that proves it was real. The work of recovering such a place is a unique science, submerged landscape archaeology. It is a kind of forensic investigation, conducted at the bottom of the sea. The event is long over, the world itself is gone, but clues were left behind, buried in the silt and sand. For centuries, the first hints came up by accident, snagged in the trawl nets of fishing boats. The bones of mammoths, woolly rhinos, and giant deer. Occasionally a barbed antler point for spearing fish, or a flint tool, its sharp edge a testament to a human hand that last touched it 9,000 or 10,000 years ago. These were isolated curiosities, but in recent decades the investigation has become systematic. Research vessels using seismic survey equipment designed for the oil and gas industry have sent sound waves into the seabed. The returning echoes are translated into digital maps, revealing what the sediment hides: the winding channels of lost river systems, the gentle slopes of ancient hills, and the hollows that were once freshwater lakes. Following these maps, researchers can send coring devices down to the seafloor, pulling up long tubes of layered sediment, and in those cores, they find the most definitive evidence: thick layers of peat. This is the compressed, preserved matter of ancient forests, marshlands, and reed beds. It is the very soil of a vanished world. What this evidence shows is not a kingdom of stone towers. It is a Mesolithic landscape, a world of hunter-gatherers and fishers who lived between roughly 10,000 and 7,000 years ago. The clues they left behind speak of a rich, estuarine environment, a northern European Serengeti teeming with life. And this is the crucial point. The loss of Doggerland is so profound precisely because it was not a myth. The disappearance of a fantasy kingdom is a matter for story. The disappearance of a real homeland, a place where generations of people were born, hunted and buried their dead, is a matter of history. It's a real chapter, torn from the book. Doggerland, then, is the foundation for our entire inquiry. It is Exhibit A. It proves, without any need for speculation, that a human landscape of immense scale can be completely removed from the map by post-glacial sea level rise. It shows that entire provinces of human experience can vanish from cultural memory, only to be rediscovered thousands of years later as faint signals in a seismic survey and dark smudges of peat in a plastic tube. It proves the principle of erasure. Our next stop will demonstrate the scale. Doggerland demonstrates the principle of a drowned world on a regional scale. Now, the investigation moves to a place that expands that principle to the scale of a subcontinent. The place is called Sunderland. To see it, you must look at a modern map of Southeast Asia, at Malaysia and the great islands of Sumatra, Java and Borneo. And then imagine turning back the clock. As the ice sheets of the north grow, the sea level falls, and the shallow seas between these islands begin to drain away. First, coastlines expand, then new river valleys appear. Finally, the islands connect, merging into a single continuous landmass, a vast tropical plain veined with rivers, stretching from the Asian mainland deep into the southern sea. This was not just empty territory. For tens of thousands of years, Sunderland was a coherent world. It was a bridge for animals and plants, a migration corridor that allowed life to flow from Asia out into what would become the Indonesian archipelago. And for ancient humans, it was a homeland. The rivers and coastlines of this now-vanished subcontinent likely supported populations for millennia. Their roots, their settlements, their entire world was configured by a geography that no longer exists. But if this vast area holds such potential for understanding the human past, it also presents an almost insurmountable challenge. The archaeological search in the North Sea is difficult. The search in the seas around Sunderland is another order of magnitude harder. The warm tropical waters, the immense river systems carrying silt, the shifting mangrove swamps, and the sheer scale of the drowned shelf have conspired to bury any potential evidence under thick layers of marine sediment. Unlike the cold, preserving waters of the north, this is an environment that often accelerates decay. The potential for discovery is immense, but the practical barriers are just as large. This is the central turn in the problem. Doggerland was a drowned heartland. Sunderland was a drowned subcontinent. The area of land lost to the sea here is vastly greater, and so the potential for a lost chapter of human history is proportionally larger. Yet the very forces that erased it, the rising sea and the tropical environment, also work to hide it from us more completely. It is a perfect paradox. The bigger the blank on the map, the harder it is to fill in. Sunderland therefore becomes perhaps the planet's most profound example of a world that is simultaneously real and invisible. Its existence is a geological certainty. Its role in human migration is a logical necessity. But its specific human story remains almost entirely silent, sealed away not by conspiracy but by silt and sea. The problem of seeing into its past is the problem of the ancient world in miniature. To understand this silence, we have to move from specific maps to a more fundamental question. In the contest against time, what kinds of evidence survive at all? The vast drowned landscapes of Doggerland and Sunderland force a fundamental question. After all the searching, with all our modern tools, why is the picture of the deep past still so incomplete? Why are the maps filled with so much empty space, and the timelines with so many silent centuries? To understand the problem, imagine the whole of human history as a library. Most of its collection, the stories, the songs, the daily transactions, the knowledge of plants and animals, was written on perishable materials. It was written on paper, spoken into the air, woven into textiles, or carved into wood. But in this library, a small special section exists where the books are carved from stone or baked into clay. Now imagine a slow, relentless flood seeps into this library, lasting for thousands of years. The paper dissolves, the wooden shelves rot, the woven bindings disintegrate. When the water finally recedes, all that is left is the small collection of stone tablets. We would read them and think this was the entire library. We would know the king lists, the tax records, and the temple dedications. But the poetry, the letters, the folk tales, the everyday texture of life, the vast majority of the collection, would be gone, and we might not even know it was missing. This is the central challenge of archaeology, and it is called preservation bias. The Earth is not a neutral archive. It actively filters what it keeps. Organic materials, wood, hide, plant fibres for baskets and rope, the remains of most meals, are designed to decay. They return to the soil, but inorganic materials, a flint spear point, a shard of fired pottery, a monumental earthwork, can survive for tens of thousands of years. This bias is profoundly amplified along the coastlines. A fishing village built of wood and reed on a river delta is one of the most fragile forms of human settlement. It is vulnerable to storms, floods, and the slow work of rot even in the best of times. When the sea itself rises to cover that delta, the chances of preservation become vanishingly small. So, the archaeological record is not a representative sample of the past. It is a deeply skewed collection of what was durable enough, or buried in just the right oxygen-free mud, to survive. It is a history written by its exceptions. This isn't a passive accident. It is an active filter which systematically removes the common, organic, everyday life of humanity, leaving behind a hard skeleton of stone, bone, and fired clay. Understanding this changes the nature of our investigation. It means that an absence of evidence is not always evidence of absence. The great mystery is not necessarily that a civilization was hidden from us by some human agency, but that the very materials of its existence may have been physically unwritten from the record by water, chemistry, and time. This gives us a crucial tool. It allows us to move from asking, "Where is the lost city?" to asking a much better question. Given the conditions, what kind of evidence could have possibly survived? We have seen the power of water from the sea and from the great glacial lakes. We have seen how time itself works as a slow, relentless filter. But some researchers argue that at the critical moment, at the threshold of the Younger Dryas, the most powerful agent of erasure came not from the land or the ocean, but from the sky. The mechanisms we have explored, the unsteady pulse of meltwater, the slow creep of the sea, are terrestrial. They are processes of the Earth's own systems waking from a long winter. But there is another reading of the evidence, another proposed trigger for the Younger Dryas. It is a story that comes not from the ground, but from the sky. This is the Younger Dryas impact hypothesis. The narrative it presents is cinematic and direct. It asks us to imagine a time around 12,900 years ago when a disintegrating comet, or perhaps an asteroid, entered Earth's atmosphere. It did not necessarily strike the ground to leave a single, obvious crater. Instead, proponents of this hypothesis argue that it may have exploded in the air above the Great Laurentide ice sheet, which still covered much of North America. The case for this event is built on a specific layer of sediment found at archaeological and geological sites across multiple continents. This thin, dark layer, often called a black mat, marks the boundary right before the Younger Dryas begins. Within this boundary layer, researchers supporting the hypothesis report finding anomalous materials. They point to spikes in the concentration of platinum, an element more common in extraterrestrial objects than in the Earth's crust. They present evidence of microscopic spherules of melted rock and glass, and even nanodiamonds, which they argue could only be formed under the kind of extreme heat and pressure an airburst would generate. The proposed chain of cause and effect is devastatingly simple. The thermal shock from the airburst would have flash melted a significant portion of the ice sheet below. This would unleash an enormous volume of fresh water into the drainage systems, potentially overwhelming the outlets of proglacial lakes like Agassiz. This sudden, massive flood, according to the hypothesis, would be the freshwater forcing event that disrupted the Atlantic meridional overturning circulation, shutting down the northern heat pump and plunging the climate back into glacial cold. It is an all-in-one explanation. It provides a trigger for the cooling, a source for the mega-floods, a reason for the widespread extinction of North American megafauna, and a cause for the disruption of human cultures like the Clovis. The sheer explanatory power of the hypothesis is undeniable. It takes a series of complex interlocking climate puzzles and offers a single, dramatic and unforgettable cause. It gives the catastrophe a moment, a face and a source. It is a powerful story. But a powerful story is not the same thing as a proven case. The scientific community has raised serious, substantial objections. But an investigation that only hears one side of the story is not an investigation at all. It is a search for confirmation. The scientific process, when it is working correctly, is a courtroom, and for every compelling argument presented for the prosecution, the defense must have its turn. The case against the Younger Dryas impact hypothesis is not a simple dismissal. It is a methodical series of questions about the evidence itself. The first and most fundamental challenge is replication. Other independent research teams have gone to the same stratigraphic layers, the same black mats, and have not found the same concentrations of impact markers. Some studies find no platinum anomaly, or report that the microspherules and nanodiamonds are either absent or can be explained by more common terrestrial processes like wildfires, volcanism, or even day-to-day cosmic dust accumulation. Then there is the question of the weapon itself, a cosmic impact of the scale required to trigger a climate event like the Younger Dryas would, critics argue, leave a significant scar, yet there is no confirmed, undisputed crater on Earth that matches the date of 12,900 years before present. Proponents suggest an airburst over the Laurentide ice sheet could explain the lack of a crater, but this too is a scenario that is difficult to prove from the geological record. The debate is a living one, constantly evolving. In a powerful demonstration of scientific self-correction, a notable paper published in 2025, which had proposed evidence of cometary dust in Baffin Bay cores, was formally retracted by the journal PLOS One in 2026, after other scientists raised significant concerns about the data analysis. This is not a conspiracy to hide the truth. It is the system working as intended, subjecting extraordinary claims to extraordinary scrutiny. The unresolved nature of the debate does not make the mystery weaker, it makes it stronger. It reminds us that science at the frontier is not a collection of settled facts, but a process of argument, re-evaluation, and a constant search for evidence that can withstand the most rigorous cross-examination. It fulfills the promise of our investigation, to mark the boundary between a powerful story and a proven physical event. The question shifts from a simple yes or no to the more profound question of what it takes to truly know something about the deep past. Whether the catastrophe came from the sky or from the slower, more complex processes of the Earth, human beings lived through it. And when people survive immense change, they do something remarkable. They remember. But how does memory itself survive for 12,000 years? In a quiet room in the British Museum, behind protective glass, lies a broken piece of baked clay. It's smaller than a modern tablet computer, its surface covered in a dense web of tiny, wedge-shaped marks. This is the flood tablet. It is in a way a message in a bottle, cast into the sea of time from the lost world of ancient Mesopotamia. Discovered in the ruins of the Royal Library at Nineveh, it contains just one part of a much larger story, the Epic of Gilgamesh, and for more than a century, it has served as one of our most direct links to the deep memory of catastrophe. The story inscribed on the clay is told by an ancient king, Utnapishtim, the sole survivor of a great flood. He tells Gilgamesh how the gods, in a secret council, decided to destroy humankind. But one god, Ea, felt pity. Speaking through the reed wall of Utnapishtim's house, Ea warned him of the coming deluge and gave him precise instructions. Tear down your house and build a boat. He was to load it with the seed of all living things, his family, his craftsmen, and the beasts of the field. Utnapishtim obeyed. He built the enormous vessel and sealed it with pitch. When the storm came, it was so terrible that even the gods were frightened by its fury. For 6 days and 7 nights, wind and water overwhelmed the world. On the 7th day, the storm subsided. Utnapishtim opened a hatch and saw that all of humanity had been turned back to clay. His boat had come to rest on the peak of a mountain. To test the waters, he released a dove, then a swallow, both of which returned. Finally, he released a raven, which did not come back, and he knew the waters were receding. This is one of the oldest and most complete narrative accounts we have from anywhere in the world. But what exactly is it? What does this piece of fired clay truly preserve? Is it the geological report of a particularly severe river flood in the Tigris-Euphrates Valley, an event magnified by time and retelling into a world-ending disaster? Is it a purely symbolic story about divine anger, human obedience, and the cycle of destruction and renewal? Or is it something else? A cultural echo, a memory passed down through countless generations of a much older and larger transformation, a time when the waters of the world truly did rise at the end of the Ice Age. The tablet offers no simple answer. Its immense value is that it refuses to be just one thing. It is not a modern scientific instrument, but neither is it a simple fairy tale. It is a piece of cultural memory, a complex layered artifact that shows how a civilization grappled with the idea of total loss and survival. It proves that for thousands of years the story of a great flood was important enough to be copied by scribes, studied by kings, and preserved in the most durable medium they had. Clay can hold a story for millennia. But an even older medium of memory exists, one that leaves no physical trace at all: the human voice. The tablet from Nineveh is one kind of archive, where memory is impressed into baked clay. But what happens when the archive is not an object, but a process? What if a memory could survive for millennia carried only in the human voice, passed from one generation to the next without a single written word? This is the world of oral tradition. For cultures that depend upon it, this is not a casual game of telephone, where a message gets distorted with each telling. It is a disciplined, often sacred practice for transmitting essential knowledge, laws, genealogies, and maps of the land and its history. Accuracy is not a hope, it is a necessity for cultural survival. Nowhere is this possibility more profound than in Australia. Researchers, including the geologist Patrick Nunn, have spent years collaborating with Aboriginal communities, listening to stories passed down through countless generations. Along the continent's vast and varied coastline, they have documented dozens of traditions from different language groups. These stories speak of a former time, a time when the sea was lower. They describe coastlines that no longer exist, naming islands that were once part of the mainland, and bays that were once dry valleys used for hunting. When these remembered landscapes are compared to the geological record of post-glacial sea level rise, the match is often remarkably precise. The stories appear to be accurate descriptions of coastlines as they were before the seas rose to their present levels. The crucial detail is that these are not generic tales of a great flood. They are geographically specific. They are tied to named places, to specific reefs and coastal plains that now lie meters beneath the waves, but whose ancient shapes can still be seen on modern bathymetric charts. The implication is staggering. The coastlines described in many of these stories stabilized more than 7,000 years ago. For a memory of that world to survive, it would have to have been passed faithfully from person to person for something approaching 250 generations. It suggests a continuous chain of memory, stretching back to a time before the construction of the Great Pyramids, before the raising of the stones at Stonehenge. This research presents perhaps the strongest case we have for cultural memory, preserving observable geological events across deep time. It does not mean every flood story from every culture is a literal report, but it proves that we must not dismiss oral traditions as simple fiction. It shows that under the right conditions, with the right cultural importance, the human voice can be an archive of almost unbelievable durability. If memory can survive so faithfully in speech, it can also be given another kind of permanence, one achieved by building it directly into the landscape in stone. If stories preserve memory in breath, and traditions carry it in voice, then some memories are anchored in stone. In southeastern Turkey, on a rounded hilltop overlooking the plains, is a place that has reshaped our understanding of the deep past. It is called Göbekli Tepe. For thousands of years it was just a gentle rise in the landscape, a man-made mound that kept its secret. But beneath the soil lay something extraordinary. Circles of massive standing pillars, quarried and carved and set in place by human hands. They are made of pale limestone, standing up to 5.5 meters tall, and are shaped like the letter T, abstract yet recognizably human-like forms. Their surfaces are alive with carvings of animals, foxes, snakes, boars and cranes. It is a silent stone congregation. The profound weight of Göbekli Tepe is not just in its scale, but in its age. The oldest layers of construction date to around 9500 BC, that is roughly 11,500 years ago, a moment poised on the very threshold between the end of the Younger Dryas and the beginning of our current geological age, the Holocene. This places it in a period archaeologists call the pre-pottery Neolithic. It is a time before widespread agriculture had taken root in the region, before the domestication of most animals, before the invention of pottery, and millennia before writing or metal tools. This is why the site is so revolutionary. For a long time, the story of civilization was told as a simple, linear progression. First, people invented farming, which created surplus food. That surplus allowed for permanent villages, which grew into towns and then cities. Only then, with the organization and specialized labor of cities, could people undertake monumental architecture and develop complex organized religion. Göbekli Tepe disrupts that clean timeline. Here was a massive, sophisticated ritual site, requiring enormous coordinated effort, built not by settled farmers, but by people who were still living as hunter-gatherers. Faced with such an anomaly, it is tempting to reach for simple, dramatic explanations, to imagine that this knowledge must have been imported, a legacy from some unknown, more advanced civilization. But that may be a failure of imagination. A more powerful question is not who built it, but why? What was happening in the world, in the human mind, that would compel communities to invest such a staggering amount of generational effort into quarrying, moving, and erecting these silent stone giants? Göbekli Tepe's true value is that it shatters the old, rigid models of the past. It shows that complex symbolic thought, communal identity, and the ability to organize massive public works did not wait for the invention of farming. Social complexity could come first. It suggests that the drive to gather, to create a sacred and permanent center, and to carve a symbolic world into stone might have been one of the very catalysts that led to settled life, not the other way around. The stones tell us what these people built and when. The deeper question is why? Why here? And why then? The existence of Göbekli Tepe, its scale, its age, its intricate symbolism, leaves us with the most important question. Not what it is, but why it is. Why did scattered groups of people at the very dawn of our current age invest generations of labor to quarry, transport, and erect these circles of stone? To approach an answer, some researchers suggest an analogy from a much later time, the great cathedrals of Europe, many of which rose in the centuries after the devastating plagues. Such projects are more than just architecture, they are collective acts of will. They are attempts to re-establish order, to build a sacred, permanent center in a world that has proven to be terrifyingly chaotic and unpredictable. They are a society's argument, made in stone, that meaning can be restored. In this light, Göbekli Tepe can be seen as a response to the long, uncertain centuries of the Younger Dryas. The evidence suggests it was not a city for living, but a regional center for gathering, a place for ritual, for large-scale feasting that would draw people together from great distances, reinforcing the social bonds that may have been stretched thin by climate instability. The pillars, carved with their silent processions of animals, were not just art. They may have been a shared cosmology made permanent, a map of a spiritual world that could anchor people in a physical world that had been in flux for a lifetime. This was a project dedicated to the invisible, a common ground for rebuilding a shared sense of the world, and this perspective fundamentally changes how we might see its builders. One popular reading imagines them as the diminished refugees of a more advanced, forgotten civilization, clinging to the last vestiges of a lost golden age. But there is another way to see them, one grounded in what we know they survived. What if they were not the inheritors of a collapsed world, but the architects of a new one? They were the survivors, the people who navigated the end of the Ice Age, who endured the whiplash of the Younger Dryas, and who emerged into the relative calm of the Holocene with the capacity to organize, to plan, and to create on a scale never seen before. Seen this way, Göbekli Tepe is not a monument to what was lost, but a testament to what endured. It is an act of profound human resilience, a declaration, carved in limestone, that the world would once again have a stable center. It is arguably the first great monument of our own geological age, built on the very threshold of this new, warmer world. It is a statement that survival is not just about enduring, but about creating. The impulse to build, to give memory a permanent form in the landscape, was not unique to the ancient Near East. Across the Atlantic in the Americas, a different kind of monumental story was being written, not in stone, but in earth. Across the ocean, and much later in time, another kind of monumentality took form. It wasn't written in quarried limestone, but in the soil itself, a language of landscape, memory, and immense human effort. In the lower Mississippi Valley of modern-day Louisiana, on a bluff overlooking the river's floodplain, lies a site that quietly rewrites the expected story of human progress. It is called Poverty Point. From the air, it resolves into a pattern of breathtaking scale and precision. 6 concentric semi-elliptical ridges ripple outwards, forming a series of nested C-shapes. These earthen ramparts, once perhaps 5 or 6 feet high, are bisected by aisles that radiate from a vast central plaza. The entire complex spans more than 3/4 of a mile. It is not a random settlement. It is a deliberate, monumental design, an amphitheatre of earth facing the setting sun. This was a UNESCO World Heritage Site long before it was widely known, a testament to an ancient American vision. What makes Poverty Point so profound is not just its size, but its age and the identity of its builders. The earthworks were constructed between roughly 3,700 and 3,100 years before present. Crucially, the people who planned and built this landscape were not farmers. They were a complex society of hunter-fisher-gatherers. This single fact challenges one of the most fundamental assumptions about the ancient world, the neat sequence that says agriculture must come first, followed by villages, then cities, and only then monumental works. The indigenous American builders of Poverty Point demonstrate this is not a universal law. The sheer scale of the labour is difficult to comprehend. Archaeologists estimate that millions of cubic feet of soil were moved, basketful by basketful, without the aid of draft animals or wheeled carts. This was a coordinated effort lasting generations, a social contract written in earth, and it was not an isolated community. Materials found at the site reveal a trade network of continental scope: copper from the Great Lakes region, more than 1,000 miles away, stone for tools and ornaments from the distant Appalachian Mountains. Poverty Point was a hub, a place of pilgrimage, trade, and ceremony for people across a huge portion of the continent. Here, the linear timeline breaks. The site reveals an alternative path to complexity, one where a deep understanding of a rich natural environment, combined with sophisticated social and spiritual organization, could produce a landscape of memory and power without a single field of domesticated grain. Poverty Point is not a precursor to a familiar kind of city. It is its own kind of centre, its own statement of order. It proves that the ancient record of America is not a simple or empty stage, waiting for familiar actors, but a place of deep, unique, and often underestimated history. Poverty Point shows a level of organisation that rewrites the textbooks. But it was not the largest city of mounds in North America. That would come later, near another great river. Poverty Point shows us that the impulse to shape the earth into a monumental landscape is ancient in America. But several thousand years later, on the same fertile floodplains of the Mississippi River, that impulse reached an urban scale that changes the map of ancient history. Near the place we now call St. Louis, a city rose from the river bottoms. Its name was Cahokia. To grasp its significance, a single comparison is useful. At its peak, between about AD 1050 and 1150, the city of Cahokia was larger and more populous than London was at the same time. This was not a small settlement or a simple ceremonial centre. It was a metropolis of earth and wood, covering nearly 1,600 hectares, organised around vast plazas and a skyline of more than 120 distinct mounds. At the city's heart stood the largest pre-Columbian earthwork in the Americas, a colossal platform mound with 4 terraces, now known as Monk's Mound. It rises 100 feet, or about 30 metres, from a base larger than that of the Great Pyramid at Giza. From its summit, a ruler could look out over a city of thousands. Some estimates place the peak population between 10,000 and 20,000 people. This was the centre of the Mississippian culture, a city built, planned and lived in by the ancestors of modern indigenous peoples. Its influence spread up and down the river arteries of the continent. And this raises a quiet but persistent question. Why is a city of this scale, a true American metropolis, not a household name in the same way as Stonehenge or the Parthenon? The answer tells us something crucial about how history can be lost. A world does not need to be drowned by a melting ice sheet to be erased from common memory. It can also be buried by historical neglect, by a story of a continent that was written to seem empty before it was, quote 3, Cahokia proves that the ground of North America was never empty. It held cities. Cahokia shows us a concentrated urban world, a powerful centre drawing in people and resources. But this was not the only way to organise a landscape. Far to the southwest, in the high desert, another kind of monumental memory was being written, connecting distant points with a web of roads and great houses. Earthworks show one kind of memory, roads and great houses show another. In the high desert of northwestern New Mexico, within the stark and beautiful landscape of Chaco Canyon, we find a different model of ancient American organisation. This is the heartland of what archaeologists call the Chaco culture, a regional system that flourished from the mid-9th to the early 13th centuries AD. The visual anchor of this world is the great houses, enormous multi-storey structures of exquisite stone masonry, some containing hundreds of rooms. They are not scattered randomly, but are aligned with precision, both to each other and to celestial events. Buildings like Pueblo Bonito are masterpieces of architecture, planned and executed on a scale that required immense social coordination and generations of labour. But to focus only on the buildings within the canyon is to miss the true scale of the system. The builders of these great houses, the ancestral Puebloan people, also engineered a network of roads that radiate outwards from the canyon for dozens, even hundreds of miles. These are not simple footpaths. They are wide, remarkably straight, and often include stairways carved into cliff faces or ramps built up from the desert floor. They connect the central canyon to more than 150 outlying communities, integrating a vast region into a single cultural landscape. This was not a system for simple trade or travel. It was a map of memory, ceremony, and social connection written onto the land itself. It suggests that for the people of Chaco, complexity was not just about concentrating people in one place, as at Cahokia. It was about creating a network that bound together a whole region, turning the arid plateau into a coherent ritual and social world. Chaco offers a third model of monumental organisation in the Americas, distinct from both the hunter-gatherer earthworks of Poverty Point and the dense urbanism of Cahokia. It is complexity expressed as a network, as a set of relationships across a vast and challenging landscape. It is memory held not just in a mound or a city plaza, but in the engineered lines connecting people across distance. Taken together, these American sites, from the first Ice Age footprints in ancient mud, to the pre-Clovis tools in a Florida sinkhole, to the earthworks of Poverty Point, the urban platforms of Cahokia, and the great road network of Chaco, tell a new story. They do not prove an Ice Age lost empire. They reveal something more profound, a deep map of American memory, far older, more varied, and more complex than the simple stories once allowed. When we step back from these individual places, from the high desert masonry of Chaco, the great earthen pyramid at Cahokia, the curved ridges of Poverty Point, the submerged tools of Page-Ladson, and the lonely footprints at White Sands, they cease to be isolated points of light. They become layers in a deep map of the American continents. This is a map far older and more complex than the one taught in most schools, a map whose coastlines were drawn by Ice Age geography and whose landmarks were built by indigenous hands over millennia. The deepest layer is a trace of simple movement, a human foot pressed into wet mud beside a vanished lake 23,000 years ago. Another layer is a trace of survival, preserved in the dark, oxygen-poor water of a Florida riverbed. Then, a layer of monumental engineering appears, built by communities of hunter-gatherers in the Mississippi Delta, organising society on a scale that was supposed to be impossible without agriculture. Millennia later, a new layer reveals a true city, a metropolis of earth and wood larger than London was at the time, thriving in the heart of the continent, and finally a layer of regional power, connecting 100 communities across a vast arid landscape through roads of ceremony and trade. It is crucial to understand that these are not chapters in the story of one single continuous civilization. They are distinct worlds, separated by immense distances and thousands of years. They represent different answers to different questions, asked by different peoples, in different climates. And here we arrive at a turn in our investigation. These sites were not introduced to prove a single theory about a comet or a flood at the end of the Ice Age. In fact, their greatest importance is not what they say about a global catastrophe, but what they say about the American continents themselves. They prove, without any need for speculation, that the idea of a quiet, empty, quote, "fore" waiting for history to begin was never true. They are the physical evidence of deep time, of complex social and political experiments, of monumental architecture, and of sophisticated landscape engineering, all unfolding across this land long before the first European ships arrived. The ancient history of the Americas was not absent. It has simply been profoundly and systematically underestimated. The ground itself remembers a story of indigenous innovation and endurance that is as deep and as varied as any on Earth. This American deep map, traced in earth, stone, and water, is not a story confined to a few monumental places. It is written across the entire continent, often in forms that are quiet, local, and easily overlooked. This brings us to a shared part of this investigation. What local mound, petroglyph, ancient landscape, or place name near you is a part of this deeper story of the land? These traces known to local communities are the unwritten pages of this archive. Seeing them and sharing them helps to redraw a map that is far richer and more complex than the one we were given. It transforms this from a distant story into a landscape we all inhabit. With all these different forms of evidence on the table, from ice cores to earthworks, we can now turn to the final questions. How do we hold all these pieces together? And what story do they tell when seen as a whole? This brings us to a question that has followed our entire investigation, a narrative that offers to connect every fragment we've examined. The idea of a lost, technologically advanced global civilization, erased by the catastrophes at the end of the last ice age. This is not a foolish question. It is a deeply human and intuitive response to the evidence. When faced with the sheer scale of the drowned continental shelves, the violence of the Younger Dryas climate reversal, the sudden appearance of monumental architecture at Göbekli Tepe, and the echoes of flood and ruin in the world's oldest stories, the search for a single, unifying explanation is not just understandable, it is almost inevitable. The established archaeological and geological records, for all their power, are full of gaps, caveats, and silences. They offer a story with entire chapters missing. The narrative of a lost civilization provides what a purely scientific account cannot, a sense of narrative completion. It gives the builders of the first monuments a backstory. It gives the flood myths a single, concrete source. It populates the drowned landscapes of Doggerland and Sunderland not with possibilities, but with a coherent world. It is a powerful story. And it is here that our investigation must hold its course with the greatest care. The path forks. One direction follows the physical evidence we can hold and test. The chemistry of the ice, the strata of the mud, the tooling on the stone, the DNA in the bone. The other path takes those same fragments and builds a story to fill the spaces between them. This second path is not one of science, but of meaning-making. It is a belief-based reading of the past. To treat this reading with respect does not mean we must accept it as fact. Instead, we can understand it as a kind of modern myth. Not myth in the sense of a falsehood, but in the classical sense. A grand story that attempts to explain our origins, to make sense of a deep and traumatic rupture, and to account for a profound sense of incompleteness in our own history. It is a narrative built to answer the silence of the broken archive. Our purpose here is not to debunk that story, but to distinguish it clearly from the archive itself. We can hold both, a sober respect for the physical evidence and its limitations, and an empathetic understanding of why the human mind seeks a more complete and satisfying answer. This clarity is the foundation of trust, so let us assemble the archive we actually have, piece by broken piece, and see what it can tell us with confidence. First, the archive of the planet itself. After considering the patterns of story, memory, and belief, the investigation must return to the ground itself. Before any human actor, there is the stage, and the memory of the Earth, written in ice, water, and stone, tells a story of profound and violent change. This is the physical archive, the baseline against which all other traces must be measured. The first and most definitive record is the ice. Pulled from the deep quiet of the Greenland ice sheet, the cores provide a timeline of temperature written in chemistry. They show, without ambiguity, the planet warming out of the last glacial maximum. They then show the shocking reversal of the Younger Dryas, an abrupt, 1,000-year return to colder, harsher conditions across the North Atlantic world. And finally, they show the sudden warming that ended it, ushering in the Holocene, our present era. This is not interpretation, it is the planet's own chronicle of its instability. The ice proves that the climate system lurched, that stability was not a given, and that the world our distant ancestors knew was subject to changes of a speed and scale that would shatter our own. The second record is the direct consequence of this changing climate, the water. As the great ice sheets melted, their stored water returned to the oceans. This is not a debated hypothesis, but a fundamental measurement of our world. Global sea levels rose by roughly 120 metres, about 400 feet. This process redrew the map of the world. It is the mechanism that turned the coastal plains of Doggerland into the bed of the North Sea. It is the force that broke the continental bridge of Sunderland into the islands of Indonesia. This rising water is the single greatest agent of Eurasia in late human prehistory. It guarantees that entire landscapes, the places most favourable for human life, with their rich coastal ecologies, were systematically submerged. The evidence for these lost worlds is not a myth, it is found in the bathymetric maps of our oceans. This sets the stage. The ice tells us when the world was unstable, the rising sea tells us what was lost, but a third record, etched into the American West, tells us how violent this process could be. The channeled scablands of Washington state are the scars left by the repeated outburst floods of glacial Lake Missoula. Here, water did not creep, it scoured. It stripped away soil and tore channels through solid basalt rock. The scablands are the geological proof that water, released catastrophically, can act with unimaginable force. It is a physical demonstration that the world of the late Ice Age contained mechanisms for floods on a scale that dwarfs any modern experience. This physical evidence, taken together, forms an undeniable foundation. This was the world stage at the close of the Ice Age, a stage of whip-soaring climate, of relentlessly rising seas, and of catastrophic freshwater floods. The crucial realization is that the Earth was not a passive backdrop for the human story. It was an active, and at times, a destructive protagonist, capable of removing entire environments from the archaeological record. This is the baseline reality. The archive of the planet itself is one of disruption and erasure. That is the story the planet tells. On top of this violent stage, we find the traces of the human actors. But the planetary archive of ice and water is not the only one. Layered on top of it, and written in a different hand, is the human archive. It is a record of footprints left on a changing shore. It tells the story not just of what was taken, but of what was made in response. Far back in the depths of the last glacial maximum, there is the simple, direct presence of a human foot pressed into the mud of ancient Lake Otero. A trace of movement from a world we can barely imagine. Then, at the very boundary of our own era, as the Younger Dryas cold gives way to the Holocene warmth, there is the sudden monumentality of Göbekli Tepe. Hunter-gatherers quarrying and carving a symbolic world in stone. A great gathering place built not in a time of placid stability, but at the close of an age of profound disruption. And across the ocean, another tradition of memory takes root, written not in stone, but in earth. It is a tradition carried forward by the indigenous peoples of America for thousands of years. We see it in the immense ancient earthworks at Poverty Point, a marvel of landscape design built by people without widespread agriculture. We see it in the urban scale of Cahokia, a great city of mounds rising from the river floodplain, and we see it in the great houses and ceremonial roads of Chaco, a culture that organized not just a city, but an entire region into a sacred map. These are not the scattered ruins of a single, forgotten global culture. They are the distinct, powerful, and creative works of many peoples across immense stretches of time. But they share a common thread. The old story often frames such achievements as products of a golden age of ease and plenty. This archive suggests a different reading. These are not necessarily memories of a paradise lost. They are the defiant acts of survivors. They are the enduring proof of human resilience, of the unyielding drive to create order, to build meaning, and to anchor memory in a world that had proven itself to be unstable. They show us that some of humanity's greatest creative leaps did not happen in spite of catastrophe, but perhaps were forged directly in its wake. and where the physical traces of human action were washed away or buried, one final, more elusive archive remains, the archive of memory itself. And finally, we arrive at the third archive. It is not made of ice or stone or earth. It is made of memory. It is the echo that follows the event. First comes the planetary change. The cold returns, the water rises. Then comes the human action, the journey inland, the building of a sacred hill. And long after, when the direct experience is gone, what remains is the story. This is the cultural memory, the final layer of the Great Archive. It is the most human and, in some ways, the most difficult to read. It survives not as a physical trace, but as a pattern of meaning. We see it in the wedge-shaped signs pressed into the flood tablet from Mesopotamia. Here, in baked clay, is a technology for remembrance. The story of Utnapishtim, the divine warning, the great boat, the salvation of life from a world-drowning flood, is not simply a myth. It is a carefully packaged warning, copied and recopied by scribes, preserved through the collapse of the very cities that saved it. It translates the terror of overwhelming water into a narrative of wisdom, foresight, and renewal. It is a community explaining to itself how to survive a catastrophe that has already happened and might happen again. The tablet is not the flood. It is the vessel built to carry the memory of the flood safely across the waters of time, and if clay can remember, so can the human voice. In Australia, among some of the world's oldest continuous cultures, we find stories that seem to hold the echo of a different kind of flood, the slow, inexorable rise of the post-glacial sea. Researchers have documented traditions tied to specific places that speak of a time when coastlines were different, when lands now underwater were hunting grounds. The geology confirms it. These coastlines were submerged more than 7,000 years ago. Here, the archive is not a physical object but a disciplined oral tradition, a living library passed from one generation to the next. It is proof that human communities, without any writing at all, are capable of maintaining an accurate environmental memory for millennia. The stories are not geological charts, but they are anchored to a real, remembered landscape. They are a map of a lost world, preserved not on paper, but in speech and ceremony. This brings us to the final turn in our investigation. The goal was never to prove that these stories are literal scientific reports. To treat them that way is to misunderstand their purpose. They are something more profound. They are the result of human consciousness grappling with catastrophic change. They are the tools we invented to make sense of a world that could be unmade in a lifetime. The question was never whether the Younger Dryas impact hypothesis is true, or whether Göbekli Tepe was built by the survivors of a single flood. The deeper question is this: what kind of world creates the need for such memories? The planetary archive gives us the answer. It describes a world of profound instability, of climates that could swing violently, of coastlines that were not fixed boundaries but moving frontiers. The human archive shows us people responding to this world not as helpless victims, but as agents. They gathered, they organized, they built massive ceremonial centers like Göbekli Tepe to impose order on a disorderly cosmos. They engineered the earth at Poverty Point and Cahokia to create permanent places of meaning. And the memory archive, the flood stories, is the software that explains it all. It is the cultural operating system for living on an unstable planet. It is the story a grandfather tells a grandchild about why the sea is not to be trusted, or why the high ground is sacred. The planetary event, the human action, and the cultural memory are not three separate stories. They are one story told in three different media. The ice core, the stone pillar, and the spoken word are all fragments from the same broken archive. So the archive is not one thing, but three: a history of the planet, a history of human making, and a history of human remembering. What then survives? After the journey through planetary forces and human resilience, through the physical archive and the archive of memory, one quiet question remains: what survives? Our own world hums with an almost unimaginable density of information. It lives in the cool, controlled air of server farms, a constant flow of light through fiber optic cables and magnetic patterns on spinning platters. We have built a global library of breathtaking complexity accessible in an instant. But this library is also profoundly fragile. It depends on a constant supply of electricity, on complex layers of software that can become obsolete in a decade, and on hardware that requires a global manufacturing network to maintain and replace. The entire system is an active one, requiring constant energy and attention to persist. Without its supporting civilization, it falls silent. The light goes out. The data, for all its richness, becomes unreadable noise locked inside dead machines. This is not a prophecy of doom. It is simply a reflection on the nature of our archive. It is an archive built for speed and access, not for deep time. And this brings a new kind of humility when we look back at the fragments that have reached us from the end of the Ice Age. The flood tablet from Nineveh is not a complex machine. It is baked clay. Its information is physically impressed into its surface. It requires no power, no operating system. It can survive fire and flood. It can be buried for 3,000 years in the ruins of a library, and, once unearthed, it can still be read by anyone who understands its script. Its simplicity is the key to its endurance. Or consider the footprints at White Sands. They were not an intentional archive at all. They are the accidental record of a moment. A person walking across wet ground on an ordinary day, more than 20,000 years ago. The memory was not stored by a mind, but by mud. It survived because of a rare sequence of events. The mud had the right consistency. It was buried by the right kind of sediment before it could erode, and it remained undisturbed until the winds of the present day uncovered it. It is preservation at its most elemental and most fragile, a ghost of a gesture that outlasted empires. And then there are the earthworks. The mounds at Poverty Point and Cahokia are archives written into the landscape itself. They are made of nothing more than soil and human labour, moved basketful by basketful. They survive not because they were technologically complex, but because they were physically massive. They became a part of the geology, their meaning shifting over time, but their presence enduring. What this teaches us is a quiet but profound lesson about preservation. It is not always the most detailed or complex information that survives the passage of millennia. Often, it is the information stored in the most durable, lowest technology medium. The story that survives is the one baked into clay. The journey that survives is the one pressed into mud, and the gathering that survives is the one built into the earth itself. The archive of the deep past does not reward complexity. It rewards persistence. And with that understanding, we can turn to the final images that have survived the great forgetting. In the end, we are left not with a single, solved story, but with the surviving fragments. We are left with the archives that endured. Imagine 3 objects side by side. The first is a footprint, preserved in the pale, sun-hardened mud of what was once the shore of Lake Otero. It is the trace of a single human life, a moment of movement from more than 20,000 years ago captured by chance. It is not a monument or a text. It is simply the shape of a foot pressed into the earth. It is the archive of a body, a singular presence in a world we can no longer see. The second is a tablet of baked clay, small enough to hold in 2 hands. Its surface is covered in wedge-shaped signs, the patient work of a scribe copying a story much older than himself. It tells of a great flood, a warning, and a survivor. It is not the event itself, but the memory of the event, encoded and made durable. It is the archive of a story, a warning passed down through generations. The third is an earthwork, a great mound or a series of long curving ridges, built not of stone, but of countless basketfuls of soil, carried and placed by a community. It does not speak in words, but in form. It is a shape on the land, a shared project that holds a people's idea of order and ceremony. It is the archive of a society, of collective work made into a landmark, a footprint, a clay tablet, an earthen mound. The archive of the deep past is broken. It was broken by rising water, by shifting ice, by the simple turning of millennia. But it is not silent. These traces, and others like them, remain. They are the quiet proof of worlds we can no longer reach, and the enduring signature of those who survived.